This is going to be probably like the last unit on modeling with systems of inequalities, but with word problems. And so these, I think, might be the most real life types of like math that we would use. And they can be a little bit challenging, especially when trying to understand like what do I use to make variables? Like how do I read the problem and correctly, categorize and organize and create things? And that's really what I want to do. So before we go into graphing everything and doing like really big word problems, what I want to do is I want to spend this video just simply writing them, and then we can talk about graphing them and analyzing their answers and whatever. So it says here for number one, you can work at most 20 hours next week. Okay, and as you're reading this, I'm going to pause for a second. As you're reading this, I want you to imagine that you have a job right now, and this whole thing pertains to you. Okay, and I know it's a little challenging, but I want you to think that you are the one doing this word problem. So, so right now you can work at most 20 hours next week. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. Write a system of any linear inequalities to model the situation. So the first thing is I'm gonna go ahead and just circle the word system, okay? Because this tells me that I need to write two or more of these inequalities. So I should have two separate ones or more. Now let's think about what we know, okay? So like what do we know? We know that you can work at most 20 hours. So at most 20 hours. Okay, and we'll talk about what that really means. You need to earn at least $92. So earn at least $92. Okay, you know that you're getting paid $7.50, okay, per hour at your car wash. No, JK, dog walking. And you were earning $6 per hour, yikes, doing car wash. All right, so here's what it's gonna be. When you're writing equations, um, you have your equal sign or your inequality sign or whatever it is. You always have your total area, right? Your total, and then you're gonna have your symbol, okay? Your symbol, and this symbol can be anything. It could be the equal sign. Sometimes it's a less than, you're greater than, less than, or equal to. Any of these symbols, right? So your choice is these four symbols that go here, and then everything else that makes up this total, okay? But they have to be the same units. So as we're going through this, okay, we need to identify what units are the same. That's what's important. So here we have hours. Here we have $92. Okay. Here we have $7.50 per hour. So this is money, right? This is time. This is money, and this is money. Okay. Which one of these represents a total? So the 92 would represent the total. So I'm gonna put that here. Okay. Now look at the word that came before that. He has to earn at least. Okay. Now, if you don't really know what that means, and I know you do, because you probably have heard it so many times. So think about this. You need to earn at least a 70 on your test to pass. Okay. Can you score 90? Of course you can. That'd be awesome. Can you score an 80 to pass? Of course. What about a 70? Right? Well, a 70 would be the bare minimum to pass. So if you score 69 on the test, you would actually fail. Even though you were close to the 70, you need to score at a minimum or at least a 92. So at least actually means anything that is greater than 92 or equal to. So at least is greater than or equal to. So he can earn exactly the 92 or anything more than that. Hopefully he earns more. And then since this is about money, everything on this side also needs to be about money. Okay, so here we have this whole thing represents money. So this entire piece must represent money. Now, what what are some things that we're talking about? We're talking about the dog walk, and we're talking about a car wash. But we can't just write that here. So what we need to do is we need to actually create let statements. So we'll let x, and you can choose any variable you want. I'm just using x and y because we see them so often. So x is equal to what? I can't just say dog walk, because like, what does that mean? Like, what are you doing that you're earning $7.50? How often is that? So this is going to be the number of hours that you dog walk. And y, that's another variable, is going to be the number of hours that you car wash. Okay, so we have these two variables. Now, we're making $7.50 for every hour that we do a dog walk, x being the number of hours, and we're making $6 every hour that we do a car wash. So now this entire thing is an inequality, and it's about the same units, money. Great. So we've actually done all this stuff out. Now, the other one is we have another total. The other total is he needs to work at most 20 hours. At most means at the maximum, which means that he cannot work more than 20 hours for whatever reason. Maybe he's in school, maybe I don't know, he's doing something, but he can't work more than 20 hours. Can he work 20 hours? Yes, he can work 20, he can work 19, he can work 15, he can work 10, but he cannot work 21 or 25. So he can work the 20, right? Exactly that amount or less than. So this is going to be a less than or equal to sign. And on this side now, this is hours. So I'm going to put a box here really quickly so I can show you this is hours. Okay, so then everything on this side must represent hours. So where are these hours coming from? Well, the hours that he works are coming from his job, and he has two of those jobs. And these variables here that we created, x was the number of hours, right? Number of hours, total hours. So the number of hours that he dog walks and the number of hours that he car washes together, that's the addition sign, has to be less than 20. So here we have our inequalities. The number of hours dog walking and car washing is less than 20, and he makes $7.50 for every hour that he dog walks, $6 for every hour he car washes. When you add them all up and stuff, you cannot, it has to be more than $92 or exactly $92. And this is how you would set up a system of linear inequalities. Okay, a system being two of them. So that's the first example. I think what you should do is, I honestly think you should pause it, read the problem, and try to figure it out. Or at least try to make the correct variables. And if you're not sure, then unpause it and then play it. But don't just watch me do the whole thing anyway. Unless you really don't understand anything at all, then I would probably go back and rewatch the video, because you wanna pause and you wanna try to figure it out first, and then see your mistakes, because that's how you will learn. Okay, so Marsha is buying plants and soil for her garden. The soil costs $4 per bag, and the plants cost $10 each. She wants to buy at least 5 plants and can spend no more than $100. Write a system of linear inequalities to model the situation. So I want you to pause this and try to think what to do, okay? And if you need help, think about what are the two things that she's purchasing. Create variables for those. So I'm going to say let x, and if you chose p, that's fine. Let x equal, now I'm not just going to write plants, okay, because what about the plants? So this is the number of plants, right? And then let y equal the number of, I guess, bags of soil. Yep, bags of soil. Cool. So now you have variables that represent this. So every time you're talking about the number of plants, bam, x. Okay. Every time you're talking about the number of bags of soil, that's y. Good. So now you have these variables. Now we're going to just write down a couple of things that we do know. Okay. We know it's $4 per bag. Okay. Per bag of soil. We know it is $10 per plant. Okay. There's a reason why we're taking the time to write down this information. Okay, she said buys at least 5 plants, okay, and then spends no more than $100. Okay. Now remember from the last problem that we did there, right? We want to have something on this side, okay? We're gonna have a symbol here, and then something on this side. Right, that's kind of what we're doing. So we have our symbol now. We don't really know what our symbol is yet, but we do know that our total is going to go here. They will usually always give you a total, and so that's what we're looking for. So let's start with the easiest ones. Okay, so let's think about this. This has to do with money. This has to do with money. This does not have to do with money, but this has to do with money. So which one of these represents a total for money? This is last one right here for $100. Okay, what we fill in here is going to be the inequality sign. So no more than, okay, I can spend no more than $100. If you go to the mall and you have $100, you can't spend more than that. Why? Because you don't have more than 100. So do you have to spend 100? No. Can you spend less than 100 and still be like it, and that's still possible? It's still okay to fit this category. Absolutely. So then you can score, you can spend exactly 100 or less than that. So this is gonna be a less than equal to sign. So this is our symbol. Okay, and these are right here is where it's gonna go. These are the units, okay, that when you add or subtract or whatever it is that you're doing will eventually come up to this total and will match these units. Okay, so I shouldn't really write units up here. Now what is going to make up this $100? Well, she's buying $4 per bag, okay, but what was a bag of soil? A bag of soil is here, that's a Y. $10 per plant. So $10, okay, for every plant. So if X is 2, that means that she bought 2 plants, she spent $20. Plus 4 bags of soil, that's 4Y. Okay, so she bought, if Y was 3, that means she bought 3 bags of soil. 3 times 4 is $12 is what she spent. So this will tell you the total amount of money that she spent buying these specific types of plants and soils. Okay, so this is all about money. Here on the bottom one now is we're still left with this guy. Okay, she needs to buy at least 5 plants. So this is just about plants. And the total number of plants is she needs to buy at least 5 of them. Okay, now at least from what we said before meant anything that was greater than or equal to. And this is a little bit trickier because they're not telling you the total amount of material she needs to get. They're being very specific to the type of a unit that we're using, and we're just using plants. So the variable associated with plants was X. So it's gonna actually just be X greater than or equal to 5, since there's no reason for us to be talking about the soil, because she just needs to buy at least 5 plants. And so these would be our system of inequalities, and this is okay. This happens actually quite a lot. You don't always have to have the same number of variables and or the same types of variables being used all the time in 2 equations or inequalities. Okay, so again, at this point now, you should totally, I would think, pause and try to figure this out. Okay, I'll answer this in another video, but you should try to pause and figure this out first and then watch that.